Hello and welcome back to MetaMath. In this video, I'm going to be covering the 2019 AMCA problem number 19. Now, before we get started, this problem was specifically requested by a viewer, so if you have any problem or topic that you would like to see covered, please drop a comment down below and I'll do my best to make a video on your request. So now, getting back to the problem, it reads as following. In a tournament, there are 6 teams that play each other team twice. A team earns 3 points for a win, 1 point for a draw, and 0 points for a loss. After all the games have been played, it turns out the top 3 teams earn the same number of total points. What is the greatest possible number of total points for each of the top 3 teams? So that's a lot of information we're given off the bat, and the first thing we can do is just assume that each team is a variable. So team 1, team 2, team 3, team 4, team 5, and team 6. It doesn't really matter which team we choose to represent our top, but I'll just choose teams 1 through 3 as our top scoring teams. And we also know that these 3 teams must have the same number of points because we're told that they earn the same number of total points. So we want to maximize the number of points each team scored, but we also want to keep them the same. Now that we have determined the maximum or the higher scoring teams, we can also assign teams 4 through 6 to be our lower scoring teams. So these teams, we want them to score as few points because we want to maximize the number of points scored by teams 1 through 3. So to do this, we assign as many losses as possible as we can to teams 4 through 6 and as many wins as possible to teams 1 through 3. The easiest way to do this is when each team from the winning side plays the losing side, we get 2 free wins. So team 3 takes 2 free wins from team 4, 2 wins from team 5, and 2 wins from team 6. We know that each team plays every other team twice, and there are 5 teams, not including itself. So 5 times 2 is 10. So we know that there are 10 possible games that each team has to play. So each team from the winning side starts with 6 wins automatically because they beat each of the teams in the losing category. Now what we have to deal with is the fact that each team from the winning side has to also play itself. So to deal with this, we want to think about how we can maximize the number of points they can get by playing themselves. Now it might seem like we want to maximize the amount of points we get by drawing, and it's very intuitive to think that drawing would maximize the number of points because by having a draw, if we have 2 teams draw, then each team gets plus 1 point and no team loses. So this would actually contribute 2 points to our total score. However, if we let 1 team win and 1 team take the loss, then that actually contributes more points because 1 team does get 3 points, but the other takes 0. And while 1 team benefits more than the other, we still end up with more points in our total system. So we want to take advantage of the fact that wins give us more points. Now, we can do this pretty easily by taking advantage of symmetry. If we assign 2 wins to 1 team, we know that the other teams must also have 2 wins. If we assign a win to another team, that would mean that each other team has to have a win, and that would actually make it impossible because we can't have every team go undefeated or with 9 wins. So what we have to do is for every win, there's also a loser. So each team takes 2 losses in addition to taking 2 wins. Now to see this, if you don't believe that this is a possible construction, just think about the final scenario. Teams 1, 2, and 3. Let's have team 1 always beat team 2. Team 2 always beat team 3. And team 3 always beats team 1. This satisfies our creation that we did right above. So each team takes 2 wins and takes 2 losses in addition to the 6 they already had. Now this is the most we can score. So this is actually a total of 8 wins and 2 losses. So that's 24 points with this creation right here. Now there are 2 other possible cases we could have come up with. We could have come up with each team doing 6 wins, then going 4 draws. We could have also had 6 wins, 2 draws, and another win and a loss. Now again, both of these points, this will total to 22 and this will total to 23 total points, but Again, the reason why we don't even have to check any of these in the first place is because we want to maximize the number of wins. And when we maximize the number of wins, we maximize the number of total points. We don't want to have any draws if possible, and we'd also like to make each team have the same number of total points. So that's why we chose this construction right here, where we maximize the number of wins and minimize the number of draws that we could avoid. So with that in mind, the answer to our problem is actually going to be 24, because we know it's not 22 and 23. So our answer is C, 24. Now right away we could have eliminated the choice E actually, and actually the choice D, which we showed could not work. We could not possibly have 26 points or 30 points for each team. Otherwise it would simply mean that they're undefeated. So if you found this video to be helpful or you enjoyed it, please consider subscribing and liking the video. If you know anybody else who could find this video useful, please consider sharing the link with them. And thanks for watching. As always, please stay safe and drop a comment down below if you have any topics or problems you would like me to cover.